Okay, so now we're clear on the question, right? Is this a conservative force? Does the work done in going from some point to some other point, is it independent of the path? So now a lot of you say yes. Why? How come you got talked out of your good position saying no? Yeah. Mm-hmm.
Any other point around it,
Yeah.
it depends on the path you take to get there. So if you go from the center out, it'll be different. Or if you go from the out.
Ooh, okay, so maybe we got to be clear on the exercise. So I'm not going to be able to draw this as well as it's up there, but tough toenails. All right, so there, same thing. Okay, so this is what we call a radial force. Okay, the force is always pointing towards a point. So we could say this force is equal to minus some crazy function of distance from the origin and pointed towards the origin. Okay? Is everyone clear what r hat means? R hat is a unit vector along the direction. So if I pick some point here, r is the vector that goes out to that point, and a unit vector in the same direction would look like that. So it depends on which point I'm talking about as to what is the direction of r. Okay? So in order to figure this out, dw has to be equal, well, is still equal to f dot ds. But I can write f as minus some crazy function of r in the r hat direction. And I can write, how do I write ds in nasty polar coordinates? Delicious, lovely, gorgeous polar coordinates. I could take a little step in the r hat direction. That part is straight ahead. But what's wrong? I'm going to make a silly assertion. What's wrong with that? Theta hat? Okay, fine. So if r hat goes that way, r hat is the direction that you get if you hold theta fixed and you extend r. And you put a unit vector in that direction. If you hold r fixed and you extend theta, you're going to walk that way. And that's theta hat. And there was much rejoicing. So what's wrong with that expression?
Adding.
What?
Adding.
Add what?
It shouldn't be plus.
Shouldn't be plus. It should be times. Dot.
Adding.
Wait. You didn't object to it here. Yeah, but that was then and this is now. Okay, fine. But here it's x hat dx plus, right? I mean, I could take a step in one direction. This is a step in the perpendicular direction. Yes, sir?
Don't you need to multiply the d theta by a factor of r?
Why, for instance, might that be a good plan?
Because if you were to move a small step theta really, really close to the center, or for instance on the center, you wouldn't move very much at all. But if you were way far away and you moved the same step theta, you would move a really small distance.
So even if I don't think about that, I'm training myself always. Check what? Okay, dimensions, but fine if you like little words. Units, okay. So this, you can't do this. That has dimensions of length. This has dimensions of, that's it, nothing, okay? It's the ratio of two lengths. Can't do this. You can't add things that have different dimensions. So you know from dimensional considerations, you need something that has the units of length. And why is r the right thing? Because if you imagine going around a little bit in theta, how long is this little segment there? R d theta. That's the length going round. Yar. Okay. All right. We'll have Pirate Day next week. If you're good. All right. So the work will be the integral of f of r dr, and going from point A to point B. Agreed? If it's radial, I don't need to know what is the exact shape of the dependence on radius. What do you think that one was supposed to represent? How does the force depend on? I have no idea. It doesn't look very credible towards the center. It looks like it's goofing off. But it doesn't matter. As long as it's pointed in the radial direction, I do this integral, what am I going to get? I just have to worry about how far away from the origin was I at point A, and how far am I at point B. And it doesn't care how much going around I did, because all the going around, the displacement is perpendicular to the force, so it doesn't count. It doesn't do any work. Yes, sir?
How would you be able to formally prove that the previous one was not conservative?
Yes. He asks, would we be able to formally prove and formally split an infinitive that the previous example was conservative?
As if mathematical.
As in mathematical. And the answer is yes. And now I'm moving on.